Hey guys, so 6.3 and 6.4 are both really short, so that's why I wanted to combine them in just one video. They just deal with one very specific operation to do with radicals, each of them, and so we're going to go through those really quickly. Just going to go quickly through 5 examples for each of them. So 6.3 is just about adding and subtracting radicals, so in order to do that, in order to add and subtract them, you have to have like radicals, okay? And like radicals means two things: same index, right? Remember, the index is the number on the outside of the radical, so like the index for these are 2, the index for these are 3. Okay, same index, but also the same radicand. And the radicand is the number that's on the inside. So you have to have the same number on the outside and the same number on the inside. Same on the outside, same on the inside, all the way through in order to combine them. Okay, once you get that, it's kind of like combining or adding and subtracting something with variables, right? Then you just kind of add and subtract the coefficients and leave the index and the radicand the same. So we're going to have to simplify first and then see if we're able to add and subtract. So this first one, right, we got to reduce all of these. We know that square root of 27 is going to be 3 square root of 3. Square root of 12 is going to be 2 root 3. And square root of 75 we break down and it's 5 root 3. So once we get to this point, we've got same index, same radicand. We can just start combining our coefficients. We've got 2 plus 3 is 5, minus 5 is 0. So the answer for this one is just 0. All right, number 2, I'm going to start breaking stuff down again. Hopefully you see that cube root of 250 here is cube root of 125 times the cube root of 2, and the cube root of 125 we know is 5. So 5 cube root of 2. Right, cube root of 54 breaks down to cube root of 27 and cube root of 2. So that's going to give us 3 times the cube root of 2. And we can't do anything with cube root of 4 because there's no perfect cubes that are inside of it. Okay, so we see that we've got same indexes all throughout, same radicand for these two, but different radicand for that one. So that means we can combine these two, but you can't combine this last one. So we do the 5 minus 3, and we get 2 times the cube root of 2. And we just leave the cube root of 4 the way it is. That's the most simple we can turn that one. All right, number 3, when you have a number on the outside, right, and then the parentheses, we just distribute just like you normally would with regular numbers. Okay, so we're going to distribute first. 6 times 3 is square root of 18 minus square root of 12. Okay, now we can try to break it down any further if we can. Square root of 18, we can break down to 9 and 2, so it's going to be 3 square root of 2. And 12 we already did up top, that's 2 root 2. That's not right. 4 and 3, I can't. Yeah, 3. 2 root 3. Okay, so 3 root 2 minus 2 root 3, they have the same index, right? They both have a 2 on the index, but different radicand. Since they have different radicand, can't do anything with it. So that's the most simple that one gets. Now number 4 here, right? A little bit more difficult because we're going to throw some fractions in here. Right? We still got to try to simplify as much as we can. Okay, cube root of 9 you can't do anything with. So this first one we can just leave as 2 times the cube root of 9. Now the cube root of 81, you definitely want to have your calculator with you to double check this stuff very quickly. I'm just going to double check. 81 divided by 27 is 3, so that means that 3 and 27 go into 81. And we know the cube root of 27 is 3, so it's going to be plus 3 times the cube root of 3. Now the last one, okay, we got to split it up. We've got, I'm just going to work with this over here first. 2 cube root of 1 over the cube root of 3. Okay, we know cube root of 1 is 1, so we don't need to worry about that. And to rationalize this, we multiply the top and bottom by the cube root of 9 over the cube root of 9. Okay, so on top we're going to have 2 cube root of 9. On the bottom we're just going to have 3, because on the bottom we would have cube root of 27, which is 3. Okay, so this is going to be minus 2 thirds times the cube root of 9. Looks just like that. Now we can try to combine anything that is like, right? We've got all the same indexes, two different types of radicands. We can combine the 9s, the 3 just stays the same. 2 minus 2/3. So what we need to do first, that's going to be 4/3. So 4 cube root of 9, or 3, plus 3 cube root of 3. That's the final. And this last one, number 5, okay, to work with this one, you have to break down as much as you can this big fraction here first, and then we'll worry about the square root of 5 after that. Okay, so let's try to break this down. Well, we could break this up into 2 different fractions, okay? Because we just have one term in the denominator, you can write it under each of these. Okay, so I'm going to do that. All right, 3 square root of 40 over square root of 8 plus 2 square root of 24 over square root of 8. Now, that works when I have one term on the bottom. If this was flipped, right, and I had both these terms on the bottom, you can't do that. It doesn't work that way. It does work when you have one term on the denominator, though. Okay. Now to continue on this, we actually don't need to worry about rationalizing these denominators, because if you notice that square root of 8 divides evenly into square root of 40 and also into square root of 24. So we just rewrite this as 3 square root of 5 plus 2 square root of 3 minus square root of 5. Okay? Just because it divides evenly, it divides perfectly out for us, so we don't have to worry about rationalizing. So now we can just combine the like radicals. We'll have 2 root 5 plus 2 root 3, and we're all finished. Okay. So in section 4, we're going to be doing some multiplying. Okay, so we're going to multiply binomials basically, and how to get rid of radicals when you have a binomial in the denominator. Okay, the key term here is called conjugate. All right, conjugates are like basically the opposite operation in between your two radicals. Okay, when you multiply these two together, the product is going to not have a square root in it. It's going to cancel out all these square roots. So it's going to be really helpful when we're trying to do that rationalizing in the denominator. So just to practice the operation first, here we've got 5. We obviously have to FOIL this. Okay, so we'll have equals 15 plus 10 root 3 minus 3 root 3 plus, minus 2 times root 9, which is going to be 2 times 3, which is 6. Okay, so I did 15 plus 10 root 3 minus 3 root 3, and I get minus 2 root 9, which is minus 6. Okay, so now I can combine my like terms of 9 plus 7 root 3. Alright, now squaring these works very similarly. Okay, so you're just going to multiply this by itself. So we've got 4 root 2 times 4 root 2. It's going to be 16 root 4, which is the same as 16 times 2, which is 32. Okay, we'll have a 4 root 6, another 4 root 6, and a root 3 squared is 3. Okay, combine like terms. We have 35 plus 8 root 6. Now, number 3, this is when we have to start trying to get this out of the denominator. So remember what I said, you can't split these up into like 2 over 1 root 3, or 2 plus root 3 over 1 plus 2 plus 3 over 3. You can't do that. Okay, so we have to multiply by the conjugate. All right, so we're going to multiply this by 1 minus root 3 over 1 minus root 3. All right, so up on top here, we're going to FOIL. We have 2 plus 2 root 3 minus 1 root 3 minus 3, because it'll be root 9. Okay, now bottom, I have 1. Middle terms are going to cancel each other out. Right, we're going to have a plus root 3 minus root 3 and minus 3 again. Okay, so now we can combine like terms. Right up on top, we're going to have 2 minus 3 is negative 1, and root 2 minus 1 is 1 root 3. So it looks like that. And on bottom, these cancel each other out, and we're left with negative 2. That's going to be our final answer. Okay, number 4, same idea. multiplying by root 2 minus root 3, root 2 minus root 3. Okay, up on top we're just foiling, so we'll have root 6 minus 3 over 2. Obviously you start to figure out that the middle terms cancel out, so I'm not even going to write them all down, minus 3. And the answer here will be root 6 minus 3 over negative 1, which you could rewrite as 3 minus root 6 over 1. Either of these would be correct final answers. Okay. Obviously you don't need the 1 there too. So last problem. Okay, we're going to do this conjugate thing one more time. And we just have to distribute on top, so 3 root 2 minus 3 over 2. Middle terms cancel out, minus 1. Right, on the bottom here, you're just going to get 1, so you don't need it. And the final answer is right here on top, 3 root 2 minus 3. That's it, guys.